This is called a transfer. It is a container within a container. The top container has the cooling area. It could be ice or it could be refrigerated area. This is put inside the second container, the cube. Warm air enters into the cube, circulates around the cooling container, and then exits, and that cold air is what is breathed. The blue area in the bottom represents the moisture that collects when warm, moist air enters and it's cooled. That's all. It's just that this has to be sealed well enough so that there's no water loss. The object of this device is to transfer cool air to the lungs, where it's got to be heated. In doing this, there's a definite loss of calories. The act of heating about 1 quart of water, which would be 2.2 pounds, 53 degrees, brings about the loss of 30 calories. The colder the incoming air, the more quickly the calorie transfer takes place. So if this were filled with dry ice, which is about 100 degrees below zero, the air that was going out might be 20 degrees below zero, and you'd be burning 60 calories instead of 30. An interesting concept with this is you can reverse this process. Instead of this being cold, it could be heated. So cold air would be coming in here. It would circulate around a heated mass, and it would be heated air coming out to the lungs. What that would do, it would be good for a person with hypothermia. At the same time, it might be a way to give medications. They would go directly to the bloodstream if they were in vapor form. So this is the transfer. Now let me show you the valve. This is a side view. This is this. This is a breathing apparatus part where the warm air would come in, the cool air would come in. When you inhaled, when you exhaled, this check valve would close and this one would open. So you can see here's our container. It would go inside the box. Cool air would come in, go around it, and then out, and that's what you would breathe. This is the top view. You can see this area where the air would be going in, circulate around a container, and go out. The application for this in particular may be for people who are in hospitals, both for heating and cooling the blood. As you cool the blood, the body has to reheat the blood, and it does this by muscular contractions. You know, when you start shaking, this happens in the body to a degree that you can't feel it, but still it's heating the blood. If you cool the blood, the body heats the blood, and that's what this does. It transfers energy, therefore it transfers calories.